Hi, so let's look at the pooling module now. So pooling module has two parts. One is the average pooling module and the other is the average pooling layer module. Okay. Average pooling module basically computes the average of the 4 pixels that is being sent to this module as an input, and it gives you the output of the averaged pixel. Okay, so we'll discuss about this more. That is, the pooling layer will send 4 pixel values as input. That is input 1, input 2, input 3 and input 4. These are the 4 pixels I'm sending as an input to my average pooling module. You compute the average and then you send it back to the average pooling layer. This is what is happening. This is this is what the average pooling layer is doing. Now you have an image. Let's say you have these pixels in the image. You have 4 pixels here, right? So these 4 pixels will be sent by the pooling layer module to the average pooling module, and this average pooling module will compute the average and it will store these computed average in the location 0. So that's how the pooling dynamics is working. Now we'll look at how this average pooling layer is working, because average pooling layer have to stride by 2. It has to continue the pooling for the entire image. For example, if the pooling is done for these 4 set of pixels, the next 4 set of pixels will now continue with the pooling. Similarly, the other set of pixels. That is how the entire pooling process is done. So it's you need address incrementing, all this logic inside the average pooling layer. We will understand how this incrementing of the address is being done. Then this average pooling layer is quite simple. It is basically computing the average and it is storing that averaged value in the uh, required location. Okay, so we'll understand how the average pooling layer module is working. Let's say you have an image which is 6 cross 6. So you have row here 0, 1, 2, 3, 4, 5. Okay. So this is the address of this image. 12, 13, 14. Similarly, you have 30, 31, 32, 33, 34, 35. This is my 6 cross 6 image. And I want to reduce the dimensions by using the pooling. So we'll discuss it iteration by iteration, what is happening in my algorithm. We'll then move on to the code. Okay. So in the first iteration, I'm initializing my pool address to be 0. My pool address is 0 and my pool row is also 0. Just for now, that remember these are the two variables I'm using. We'll discuss the use of all these variables slowly. So the moment you assert the reset, so my logic is somewhat like this: the moment you assert the reset, your pool address will be initialized to 0, your pool row will be initialized to 0, and your first set of pixel, what will be my first set of pixel for which I'm doing my pooling? That is, the first set of pixel will be the 0th pixel, the first pixel, the 6th pixel and the 7th pixel. The 0, 1, 2, 3, 4 are basically the pool address, the image pixel address here. Okay, now the value of this pixel, it is the pixel address. So the moment you assert the reset, my module knows, the average pooling layer module knows, okay, the user is asking me to start the pooling. And the moment I know that I'm starting my pooling, I know what will be my address. My address will be 0167. So how do I generalize this and write it into equation? My in1 will be pool address. Why? Because pool address is initialized to 0. I know my in1 is the 0th pixel. What will be my in2? In2 is my first pixel, so that can be written as pool address plus 1. What will be my in3? In3 can be written as, pay attention, pool address plus n. So this is quite important. N is the number of rows. What is the number of rows here? I have taken a 6 cross 6 image. My number of row is 6, so pool address will be 0 plus 6. So in3 is 6. Now what will be in4? In4 will be pool address plus n plus 1, which is 7. So that is how I'm achieving the address of the first 4 pixels as soon as you assert the reset. Now we'll take a look at the first iteration. Okay, first iteration after reset is asserted. What happens? So I know my equation, pool address is pool address plus 2 and my pool row is pool row plus 2. These are the equations. Okay. So that is basically for the first iteration. Since my pool address was 0 initially, it will become 2, and this will also, pool row was also initialized to 0, so this will also become 2. So what will be my pool in value? I know my pool in value is equal to pool address, so that is 2. In 2 will be 2 plus 1, which is 3, and in 3 will be pool address plus the total number of rows, or you can say it is 2 plus 6, which is 8. My in 4 is the pool address plus total number of rows plus 1, which is 9. So my next set of pixels for which I need to do the polling is 2, 3, 8, 9. What was the first set of pixels? The first set of pixel was 0, 1, 6, 7. And as you can see in the image, the next set of pixel is 2, 3, 8, 7. That is what we have achieved here. 2, 3, 8, 9. And that is what we have achieved here using the equations. These are the equations that are used to compute the address of the pixels. And how are we computing the address of these pixels? Using the pool address variable. Now, one more thing to note here. After computing the address of these pixels, I know my next set of pixels are the second pixel, my third pixel, eighth pixel, and ninth pixel. What do? I send this as an input to my average pooling module, the one discussed earlier, the average pooling module. This is my average pooling module. So you send all these pixel addresses, that is all these 4 pixels to my average pooling module. The average pooling module will compute the average, that is add and divide by the total number of pixels. It will compute the average and it will store in the 0th location. Similarly, then the next set of pixels will be computed and the average value will be stored in the first location. Okay, so in the required location, your pixel value average will be stored. So how is the dynamic going? Average pooling layer is taking and computing the address of the pixels for which the pooling has to be done. Those pixel values from the required address is being sent to the average pooling module. The average pooling module is computing the address. It is sending it back to the average pooling layer module. Now what is happening in my second iteration? My second iteration, my pool address was initially equal to 2. Now it becomes 2 plus 2, which is 4. My pool row also was initially 2. Now it becomes 2 plus 2, which is 4. What is my in1 value? In1 value is pool address 4. In2 value is pool address plus 1, which is 5. In3 value is pool address plus total number of rows, which is 10. In4 value is pool address plus total number of rows plus 1, which is 11. So what is the next set of pixels? 4, 5, 10, 11. Let's verify this in the image. So after 2, 3, 8, 9 is done, what is the next set of pixels? 4, 5, 10, 11. Now here comes an important point. The moment you reach 4, 5, 10, 11, I know I have reached at the end of, from the visual explanation, from the visual, it's evident visually that you have reached the end of the row, 4, 5, 10, 11. The next stride has to be done here. This is what I need to achieve. Okay. How do I do that? Here, little bit change will come in pool address equation, because directly from 4, 5, 10, 11, I want to have my pixel value to be 12, 13, 18, 19. And here, your pool address comes into picture. Now we'll see the importance of pool address to compute this next set of pixels. See, what happens is, in your third iteration, your pool address becomes 4 plus 2. My initial value of pool address was 4. You add 2 to it, and this is consistent across all the iterations. You get the value of 6. Now you get the pool row value, which is again 4 plus 2, 6. The moment you get 6, see, in my code there is a condition where if the number of row is equal to n, the moment you reach this condition, n here is 6. The moment you get the pool row value, that is, this is not the number of row, this is pool row. The moment pool row value is equal to 6, you have to make some changes. What are those changes? The changes is like this. Your pool address will be modified to this equation. Pool address will become the previous value of pool address plus pool row. So, sorry, not the previous value of pool address, the current value of pool address plus the current value of pool row will become the new pool address value. So that will be 6 plus 6. So it becomes 12. Now you can continue with the previous methodology of computing the pixel address. Your in1 will become pool address, which is 12. In2 will become pool address plus 1, which is 13. In3 will become pool address plus total number of rows, which is 12 plus 6, which is 18. In4 will become pool address plus total number of rows plus 1, which is 19. So you get 12, 13, 18, 19. Let's verify whether these are the next set of pixels I need. Yeah, correct. So 12, 13, 18, 19. These are the next set of pixels I need. And why am I able to achieve this? I'm able to achieve this because I have modified the equation for pool address since I know I have reached the end of the row. That is the importance of pool row, and we have understood why we need pool address. So we'll look at the uh, algorithm in code, and this was basically a simple numerical example to make you understand what's going on in the code. So now we'll take a look at the code. Now we'll discuss about the pooling module. This is the average pooling module. So the inputs for this module is input 1, 2, 3, and 4, which are basically the 4 pixel values. Uh, so this is the code here. This is the average pooling layer. So we have discussed that pooling requires two modules, which is average pooling layer and average pooling module. So we'll first look at the average pooling module. So we know what this average pooling module is doing. It is taking my 4 pixel values, and then the moment your enable is 1, that means your pooling layer module is saying that okay, proceed with this pooling. Proceed with the pooling for these 4 pixels. These 4 pixels are taken as input. The average for this is computed. Okay, so this right shift by 2 is basically dividing by 2 to the power 2. Okay, right shift by n. For example, here in1 plus in2 plus in3 plus in4, right shift operator. Then if n is written, this means you divide it by 2 to the power n. Since the n value here is 2, I will divide this entire sum by 2 to the power 2, which is 4. So this is nothing but averaging the pixel value. That is given as the output, and you assert done as 1. And what is this done equal to 1 doing? As soon as done is asserted, that value is being sent to your average pooling layer. My average pooling layer gets an indication, okay, the pooling is done for these set of pixels. Let's compute the address of the next set of pixels, and this is how the pooling continues for the entire image. Okay, now let's look at the average pooling layer. What is my average pooling layer? This is the parent module for the average pooling module. So here all these are inputs. Now okay, so in the previous case I have told you that the moment you assert the reset, this is the initialization. And why am I initializing this? Let's see from this case. See, if reset is asserted, you initialize your input 1 address, input 2 address, input 3 address, input 4 address as 0, 1, 28, 29. I know that my image is 28 cross 28. In the previous example, I have seen that the pixel value address is initialized as 0, 1, 6, 7 because the total number of rows was 6. Okay, so pool address plus 1, pool address plus n, pool address plus n plus 1. This is what is happening here. Pool address is 0, pool address plus 1 for the first case is, for pool address for the first case is 0. So pool address 0. My second pixel is pool address plus 1, which is 1. My third pixel is pool address plus n, which is n here is 28. So 0 plus 28 is 28. My input 4 is pool address plus n plus 1, which is 0 plus 28 plus 1, which is 29. Okay, so this is the initialization. If reset is asserted, you initialize all these to 0. The 4 pixels address is initialized to 0, 1, 28, and 29. That's how you know, okay, start with the pooling. Now let's look at, see all these 4 pixel address. So basically the 4 pixels. Pool in1, in2, in3, in4 is being sent to the pooling module. How do you achieve this pool in1? Pool in1 is basically the pixel value with address of pool in1 address. So 0 is the in1 address. 1 is in one address, 28 is in one address, and 29 is in one address. So that the address, if you know the address, it's quite easy. This image is basically acting as a memory. In that memory, you know the address, you'll take out the value from that memory, and then you pass it onto the average pooling module. So all these pixel values are being loaded into the average pooling module, and then the finished pool is asserted. That means done is asserted, and the value, the output, is being stored in the pool final. That is sent back to the this parent module. Okay, so this is the reset part. Now, if enable is equal to 1, that means compute pooling. What all things we do? See, if finish pool is asserted, this means the pooling of the set of pixels I have sent to my average pooling module is computed and it is sent back, and finish pool is asserted. Pool final, that is the final output. The final output is being whatever is obtained. What is pool final? See, the average pooling module is computing pool final. Pool final is the output of the average pooling module. So that output is being stored in the pooled image. And what is the address? At what address is it stored? It is stored at the pool final address. Pool final address was initially 0. So the first set of pixel average will be stored in 0th location, and then this pool final address will be incremented by 1. So the next set of pixel average will be stored in first location. Like this, it goes on incrementing and it goes on storing the pool final value in the pool final address. So this pool is basically your pooled image, and this is the original image. This is the original image, and from the original image, sorry, this is the original image, and in this original image the pixel values are sent to the pooling module. Those pooling module, the average is computed, and then the final value is being stored in the pool image. Okay, now we have seen this, why we do it +2, why we do +2 here, pool address +2, pool row +2. Okay, that is the way you are incrementing the address and the row. So we have seen this condition why pool row is maintained, because you have to stride by 2 the moment you reach the end of your rows. So we have seen this previously with a numerical example. I have reached the end of the row, that is my pool row has become 6. I have reached the end of the row, so I will come down by 2. So in order to do that, I'm maintaining this pool row by 2. So in this case, since my original image is of size 28 plus 28, here I will compare if pool row is equal to 28. In the previous numerical example, what did we do? If pool row is equal to 6. Here what am I doing? Pool row is equal to 28. So if pool row is equal to 28, I will add the pool address and the pool row. We have seen this in the previous case. We have added pool address, which was 6, and pool row was 6. 6 plus 6 was 12. So that was the modified pool address, and that is how you compute the address of the next set of pixels. The moment you reach after you reach the end of the row, the next set of pixels are being computed using this modified pool address. So this is the condition, this is the pool address, modified pool address, when you reach the end of the row. Now, what other things that can come up? The other thing that could come up is, what if you reach the last pixel? Last pixel means I know my pixel is from address 0 to address 783, because there are total 784 pixels. So the last address, the highest address I can achieve is 783. What if your fourth pixel is at 783 location? This means you have reached the end of the pooling. You have computed the pooling of the entire image. That's why pool enable is set to 0. Okay, pool enable is set to 0 means, okay, the computation is over. Your entire pooling is done. Okay. Otherwise, if your pool row is not equal to 28, and if your pool address, the pixel 4 address is not equal to 783, this means a normal pooling is going on. What do you do in case of normal pooling? In case of normal pooling, we have seen in the previous numerical example also that if the fourth pixel is not 783, this means you have not reached the end of the pooling. You have not completed pooling for the image. What do we do? The first input pixel address is computed using pool address. Second input pixel address is computed using pool address plus 1. The third input address is computed using pool address plus n. N in this case is 28. In our numerical example, it was 6. And the fourth pixel address is computed using pool address plus 29, which is pool address plus n plus 1. Okay, n here is 28. And final address is computed here. Final address is incremented because you send these 4 pixels to your average pooling module. Average pooling is computed, and it is stored in this address. Initially, my pool final address was 0 when reset is exerted. It increments in the next iteration to 1. In the third iteration, increments to 2. And this is basically computing the address for your modified pooled image. This pool final address is the address of your modified pool image. And that is why your entire result is being stored for the set of pixels you are sending to the average pooling layer. That is how this entire algorithm works. I hope the numerical example was quite helpful to understand this algorithm. We'll now discuss about the dense layer and the neuron module as we go further.